topic is evaluating the performance of feature extraction techniques using classification techniques. So this is an extract from my paper. Basically, this abstract is defining this introduction that we are going to use five dimensionality reduction techniques named Principal Component Analysis (PCA), Independent Component Analysis (ICA), Locality Linear Embedding, Locality Binary Pattern, and Simple Autoencoder, with the use of algorithms, classification algorithms especially, SVC, also known as Support Vector Classifier, LDA, Logistic Regression, K nearest neighbor, and Support Vector Machine on the specialized data Olivetti dataset. So yeah, this is the objective to find the best pair or a couple of dimensionality reduction and classification techniques. So first of all, let's understand about about this data set. So this is a Kaggle data set. So not my personal data set, but this is a data set developed in April 1992, and between 1994, yes. And this is actually a facial data set, and in gray images, with about 400 face images in the data set. And size is 64 into 64 in height and breadth of pixels, you say. And this as I told, this is a gray image of different 40 different identities. So yeah, let's move forward with some definitions. So first definitions we are gonna define is dimensional reduction techniques, which is first is principal component analysis. Basically, principal component analysis dimensional reduction technique does is it separates the data into its normal axis and gives us a 2D space of its normal form. As you can see in this and picture, that it is making a PC1 and PC2 data is orthogonal axes, and it is representing this data set into its own axis, or say on plane. That is how it reduces the data set and help in normalization of this data set. So yeah, this is one of the techniques that we are going to use. Second one is independent component analysis. This is bit different from PCA. It Although it is the same type of dimension reduction technique, but it is uses independent separation of the data set. As you can see, that there is an S1 voice and S2. If you give the mixture of S1 and S2, simply it will release both in different form, both in separated independent form of S1 and S2, removing the common part. This is one thing. This is the main question arises to everyone. What is the difference between PCA and ICA? PCA generally compresses both information, like there are different information. It compresses both information into each other and reduces that way. But whereas ICA just separate the information from the compressed data. That is like you can see here. ICA separates information. Yes. So this is one of the definitions. And moving to locally linear embedding, it's a although an algorithm, it generally finds its neighborhood particles, neighborhood data, and makes its own structure and compresses it. So as you can see, it gives the weight to compresses its own data points. And this is exactly this how it compresses the data with the help of its neighbors. Now next is locality binary pattern. So locality binary pattern is just it just uses this pattern reduces the pixels. So is formula. and like you can see, this is one generating local binary pattern, and this using this formula it reduces the pixels and hence decreasing the size and um, decreasing the size, compressing the image. As you now, this is the advanced and the latest compressing technique. This was so simple autoencoder. This autoencoder is a neural network base that compresses the data to compresses and encodes the data actually. That due to the use of neural networks, it's learned how to reconstruct the input image with the compressed pixels. So this is the result of this paper. First of all, we we take five dimension reduction techniques and these five classification techniques, and we find each of the best each of the best couple. We find accuracy technique to find best accuracy in this. As you can see, uh, I have given that linear discriminant analysis with autoencoder is the best. So if you go here, you will realize this is the best upcoming accuracy in this. Although PC and IC are also giving good accuracy in this, have little slightly difference. So that's why most people use PCA and ICA in new models, because autoencoder could be bit difficult to train and PCA ICA are easily available. In this, best classification technique is linear discriminant analysis in all of it in average, whereas the worst is local binary pattern with KNN. So if you see local binary pattern, it's just giving 0.541, and all in average KNN is the worst classification technique. You can also check it from the graph I have given. Uh, there could be much discussion that why are these KNN and local binary pattern couple is doing worst in this. So there are many reasons. There are many reasons, like there's a dimensionality reason, linear, because there are high dimensional feature vectors, and KNN can take such a high amount of features and could be underperforming because LBA are uh, due to applying LBA, it is creating more vast features and not normalized equally. So KNN if effectiveness decreases due to the high amount of features and unnormalized features. So it is also creating less feature. It's called combining these features, making a cluster, and it is not differentiable exactly using the linear binary patterns. So that's also the one of the reasons that KNN might struggle to work. Another reasons could be local patterns, as the capability of linear binary patterns, it generates the pixel by taking local texture, which is not really good for classification tasks. And KNN might not program well as it is a basic classification, one of the basic classification techniques, and that's some reason. And sensitivity is one of the main thing that comes in every classification uh, technique, that due to the high noise and yeah, separating pixels or blurry pics, this can't be accurately classified. Parameter, yeah, basically too much parameters are there, So KNN is generally confused and can't perform that well. So basically, before going to the further, I just want to say that in the back, what we did in this classification is the motive of this mainly is to find the best technique, dimension reduction technique in the newer models. Is for smaller data sets because as we know the Olivetti data set as we have shown is not a much big data set. Okay, so yeah, and this is only 400 face images and also gray image. So it is not much bigger. And this is generally for the when you are using smaller data sets and we are generating different classification techniques without any use of normalization techniques and any different techniques. This is the finding of the best classification techniques and dimension techniques and also there on the couple of both of them. So not only as we see, as I told you before, that PC and IC also work with simple autoencoder. You can see there are different working like LDA or the better, like you see SVC in PC and IC or IC also working better, and all those LR but and STM are working bit better. So it could be different on the basis of your data sets, your feature extraction models. But for basic model without any normalization and this is the best. This LDA is best with simple autoencoder and PC and IC can be could be worked upon. So yeah, that's so as I have told you, there are certain losses in KNNs. Although the KNN is not the problem here. KNN is not the problem. The problem mainly is the reduction techniques is more having separate unnormalized. There is more noises and in the new pixel division. So that's why it's working the least. As you can see, this is the only one of the going through sevens and five because this is not working according to the classification because of these things. KNN is also weaker in this particular data set as it is has due to far away features and different high value differences in features. So that is the presentation, I think.